Okay, great noon, good afternoon all. And today we are just going to see about cogeneration, right? So energy management on cogeneration. So before entering into energy management on cogeneration, so we should know about what is by cogeneration, right? So I think my batch two students already they know, but new people are coming from orchestra batch, right? So anyway, with a little speed, right? So with the help of details fast, I'm just going to recall about cogeneration, and we are just going to continue our previous classes, right? And what is my cogeneration in the sense? So the name itself has some meaning, right? So it's going to generate something, but it's going to generate two types of energy at the same time with a single input. That's exactly the same meaning. So you could have. I'm just going to give you overall introduction, and then we'll just proceed, right? So in traditional method, that is called conventional technology, how the heat and electricity is generating actually. So we already know these are the traditional method, this conventional method. So they are converting natural gas, coal energy, right, into electricity with the help of turbine plus generator with alternate, right? So for example, they're just converting coal energy into steam energy. Steam is now again converted into mechanical rotational energy. Mechanical rotational energy is now converted into electric energy. So this is one way of generating electricity. In the same way, heat energy also is going to be generated like this, right? So this is called conventional method. So in a cogeneration method, right? So the simultaneous production of electricity and steam from a single fuel source. That's the exact thing. So energy efficiency will be somewhat 86%. That is called near 90% in cogeneration. But in my conventional method, will only able to get a 55 or 14.8, right? So based upon survey, only this much efficiency we could able to yield it, right? So cogeneration is nothing but we are just going to produce electricity and heat energy, right? So both things is going to be utilized by industry or home appliances, right? So with a single input and natural gas, maybe cold energy, and we have different energy, right? So we are just going to use both electricity as a heat energy, and as well as we are just getting and simultaneously from a single source power, right? And in a conventional method we are getting individually. So in my batch students already they know, right? So I have already taken, right? So electricity in the sense, for example, we are just consuming grid electricity which is generated from away around 300 kilometer from away. So because the thermal station will be, the power generation will be around 200 kilometer away. So they could able to transmit only electrical power with the help of transmission lines with conductors, right? So they couldn't able to transmit heat energy from around 200 kilometers. They won't able to transmit that much heat energy. So as a customer, right, so we need to use heat energy in the sense we need to again consume more electricity from grid, right? So these are the small big drawback in conventional method. If it is a cogeneration, in the sense we could able to use both the thing at the same time. So what is the difference in the sense? The conventional method, the power generation factory or power generation power plant, it will be located from away from a customer, right? So it will be around the 200 kilometer, 300 kilometer away. But in cogeneration, so you could able to install your own micro level power plant nearby your residential area, or maybe nearby your industry or inside that campus, right? So you could able to capture heat energy as well as electricity. So this is the most advantage between compared to my conventional technology. So this is overall introduction about the cogeneration, and we're just going to continue. So என்னுடைய பேட்ச்க்கு மறுபடியும் ரிப்பீட் பண்ற மாதிரி இருக்கும், and that's why I'm just going to moving little faster, right? And this is a principle. So we are just going to convert these different types of fuel energy into electricity as well as power. We are just going to create, or as well as we are just going to utilize electrical power as well as heat which is developed inside that say entire power generation system. We are just going to acquire this heat, and we are just going to utilize this heat in for different applications, right? In our thermal power plant, so they are using their heat, right? So, but as a customer we couldn't able to get it, right? So again we need to depend upon electrical power supply. So how it's going to convert, right? So with the help of we are having just a system that is in the system is now going to convert into this type of power. So with this vegetable oil, bioethanol, heating oil, natural gas, coal, biomass, and municipal waste, and human home waste, household waste, right? We are just like these things are called my energy, and this is now act as now fuel to this my entire system. So the system பார்த்தீங்கன்னா IC engine இருக்கலாம், இல்லைன்னா gas turbine இருக்கலாம், or fuel cell, or maybe steam turbine, whatever maybe. So these are all the things is called prime mover, right? Actually, this is called prime movers, different kind of a prime mover. So this prime mover is now going to be connected with my generator, and it's going to be generate electricity. So this is what one of generation, as well as here there is a energy conversion is taking place, where that this type of energy is now going to be converted into electricity energy. Definitely inside there is a one more byproduct is coming, that is called heat. So on the heat, we are just going to recover it, and we are just going to test for a residential as well as industrial appliances. So this is why it's called cogeneration. So we are just going to generate power and heat from a single fuel source. That's why it's called combined heat and power. That's why it's called simply they will call it as CHP, combined heat and process system. They will just simply call it as, right? So in our industry people, they won't call it as cogeneration, they will call it as CHP. That is called combined heat and power. That is why heat and power, that's why it's called CHP. They will call it as CHP. And what is a cogeneration? Yes, a process in which the industrial facility uses waste thing, right? So these are the waste thing, right? So vegetable oil, bioethanol, municipal waste. This entire waste is now going to be converted into heat or electricity. So this is why it's a formal definition about our cogeneration. So the simple recalling purpose, burns energy once, right? So the simple meaning you could able to easily recall, burns energy once but uses it twice. So the twice enகிறது என்னது, electrical power and heat. So these are the two things. So power and heat, that's called uses it twice. So once burns once and that uses twice. This is called cogeneration. And it also what could I say? So we'll go with the history, as it will be late 18th century. They started around 800 above, right? So steam நாங்க reduce find out பண்ணாங்க, அப்பவே that thing is now got rectified. So it's very olden technique, and this is one type of natural gas cogeneration. How it's going to operate, right? So simply I'm just going to make it a little faster for it. So fuel we are giving, that is called natural gas, we are just going to allow. And here the gasoline engine is now here, gasoline engine, right? So gasoline engine, that is called internal combustion engine, will be here. I'm just going to apply compressed air as well as natural gas. Is now combustion is taking place inside the combustion chamber. Definitely the piston is going to be moving up and down. That is called my 2-stroke or 4-stroke engine. So definitely there is a piston is moving upward, downward. That piston arrangement is connected with the crankshaft, and the crankshaft is going to be connected with my driven shaft. And then driven shaft is now running, this rotating. That rotating shaft is now connected with my generator, and generator is going to be generate electricity. And definitely here the maximum that in combustion chamber there is a fire is going to be generated because of compressing happened here. So that's why there is a huge amount of heat is going to be developed, as well as natural gas is now converted into flue gas. That is called exhaust valve, that is called exhaust level. The exhaust flue gas is coming, but the exhaust has is having some what could I say, that maximum heat energy they hold பண்ணிருக்கும். அந்த heat energy நான் அப்படியே வெளியில விடாம என்ன பண்றேன், I'm just using heat exchanger in between my exhaust thing. So heat exchanger is going to be converting a normal water into hot water, right? So because of conversion principle, right? So that a normal cold water is getting more heat from this flue gas, and water is now getting warmed, right? So that is called hot water connect பண்ணலாம். Otherwise you could able to convert to steam, and you could able to heat our room, right? So this is the different kind of applications you could use, right, with the help of this flue gas. And then you could exhaust that entire remaining gas, right? So this is one type of cogeneration. This is called natural gas generation. If you're using diesel power, right, so you could able to call diesel cogeneration. If you're using petrol, you could call petrol cogeneration. If you're using steam, that is called steam cogeneration. What's the type of fuel you are using over here? That's why the name is somewhat different. And it will help you, right? So it could help you, right? So you could able to increase your efficiency, plant efficiency about 70 to 90%, because we are utilizing heat as well as electrical power. So that's why the efficiency will be very high. And this is a comparison between my traditional power plant and cogeneration power plant. So traditional power plant will be 50% only. So remaining percentage எங்க போச்சுன்னு பார்த்தீங்கன்னா around 4 to 8% transmission electrical loss, and the generation itself we are just only generating about 80%. So and அங்க reduce our heat பார்த்தீங்கன்னா remaining 20%, right? So remaining 20% will be lost at generation station itself. But in cogeneration only loss பார்த்தீங்கன்னா 10 to 15%, because we are using heat energy also, we are using electricity also, we are using. So the total fuel energy is now somewhat 85% is now converted into usable energy. Only 15% is going to be wasted. We couldn't able to capture exact heat energy, right? So எல்லாத்தையுமே நம்ம capture பண்ண முடியாது. There is a losses will be going to happen, right? So we are not having a 100% good heat exchanger நம்மட்ட இல்ல, heat exchanger. So there is a heat also is going to be eliminated in those heat exchangers. So that's why somewhat it's quite good compared to my traditional method. And components of cogeneration. So very important 2 mark question also, right? So component of cogeneration. So இதுல பாத்தீங்கன்னா தெரியும், this is called a natural gas cogeneration system. So இதுல என்ன part involve ஆயிருக்குன்னு பாத்தீங்கன்னா fuel handling system and generator and piston arrangement, that is called my engine, and exhaust heat exchanger. So these are the major parts which is involved in this cogeneration technique. The same way in commonly speaking, components of cogeneration. So what are the components will be going to be involved in cogeneration? So definitely it needs a prime mover, right? So it needs a prime mover, because cogeneration meaning we are just going to generate electrical power, right? So we are just going to generate electrical power, but definitely I need a prime mover, I need a generator. So second point, generator. So because of cogeneration itself, it has a meaning, we are just going to generate electrical power, but definitely again prime mover as well as a generator setup. So that's a major important parts, prime mover and generator. For a prime mover, it needs to convert some energy, right? So it needs to getting input, and we are just going to convert it into common rotational energy. That's the objective of prime mover. So for prime mover, we need to give a energy that is called fuel energy. And the fuel பார்த்தீங்கன்னா wind mill இருக்கலாம், or hydro இருக்கலாம், or diesel இருக்கலாம், or petrol இருக்கலாம், or gas இருக்கலாம், or steam இருக்கலாம், or whatever may be, right? So it needs energy. This entire different kind of energy is now commonly converted into electrical energy. So but this is called my fuel. So and third is now fuel, right? So once the conversion took place, right? So definitely there is a waste is now coming. So on the waste, and then I could able to convert again and some energy, that is called my heat recovery system. We are just going to go with it. The entire system is going to getting heated, so I need to reduce the temperatures. Definitely I need a cooling system. So arrange பண்ணி பாருங்க, prime mover is needed, generator is needed, prime mover input is needed, that is called fuel system. Fuel system burn பண்ணீங்கன்னா heat recovery ஆகும், heat நான் reduce பண்ணிக்கலாம், reheat நான் use பண்ணிக்கலாம் for a further process. If the system is going to be entirely get heated, so I need to cool it down. So definitely I need a cooling system, right? So I need a ventilation system also to reduce the temperature, and எல்லா system I need to monitor and control in a precise manner. So I need a control system, right? So entire thing I'm just going to go with it explosion proof or dust proof, right? So we'll just go with it enclosure. So got a linking between everything, right? So this all every section is going to be, every system is going to be have an interlink, right, between both everyone, right? So totally 8 components will be involved in any cogeneration: prime mover, generator, fuel system, heat recovery system, and cooling system, and ventilation air system, and control system, and enclosure. So these are the common components will be available in cogeneration. So very important thing, right? So we need to consider. And then types of cogeneration. So what are the types of cogeneration? So the type generation is commonly classified into 2 types, that is called topping cycle power plant and bottoming cycle power plant. So what is called topping, what is called bottom? So topping in the sense there is a topper, right? So the meaning itself topper. Bottom in the sense at last, right? So at last. So in our class pathina, for example I'm just speaking topper அப்படின்னு சொல்றோம் இல்லையா, that's called primary person, right? So primary objective. That's a topping cycle in the sense the cogeneration of the meaning another, we are just going to generate a 2 power, electrical power, and we are just going to generate heat power, that is called heat. So we are just generating 2 power, that is called electrical power as well as heat energy, right? So from a single input, single power source, so single fuel. So then cogeneration. So if you're having two types of energy, that is called, one is electrical energy, right? So one is electrical energy, second is heat energy. If you're just having your primary objective is to generate electricity in the sense, that is called topping cycle power plant. If our primary objective is to generate electrical power in the sense, even in cogeneration plant, right? So even in a cogeneration plant, your primary objective, right, your goal is to generate electricity in the sense, that is called a topping cycle power plant. If you're having a primary, right, so if you're having a primary goal about to generate a heat energy in the sense, that is called bottoming cycle power plant. So this is a major difference between your topping cycle and bottoming cycle. So the difference is nothing but, if your primary aim is to generate electrical power, that is called topping cycle. If your primary aim is to generate heat, that is called bottoming cycle. So in further, topping cycle is now converted into again four types, that is called combined cycle CHP. I told that CHP in the sense, anyone just give me CHP, and anyone just give me CHP in the sense, what is meant by CHP? Anyone? What is meant by CHP? Around 45 members நம்ம கிளாஸ்ல இருக்கோம். What is meant by CHP? What is full expansion? நான் இப்பதான் சொன்னேன்.
Combined heat and power.
Yes, combined heat and power. Thank you, Manoj Sarath. Thank you a lot. Thanks a lot. Yes, at least I'm just getting recall, right? So whether you people are listening or not, that's why I'm just asking. So you'll get more knowledge, right? So go with it. I'm also having one more software for cogeneration. So whatever I'm taking, I'm having a software. So no issues. Resume நிறைய software போட்டுக்கலாம். Definitely will get a more knowledge, right? So just to follow me, right? ஸோ அதர்வைஸ் உங்களுக்கு நிறைய தெரிஞ்சு நீங்கள் go ahead எனக்கு முன்னாடி நீங்கள் நிறைய கற்றுட்டு போயிட்டே இருங்க, ரைட்? நோ இஷ்யூஸ். ஸோ நவ் வில் ஹாவ் ஃபோர் டைப்ஸ் ஆஃப் topping cycle power plant. That is called, one thing is combined cycle CHP, and second thing steam turbine CHP, and then third one internal combustion engine CHP, and fourth one gas turbine CHP. So these are the various four types of CHP plant will be available in a topping cycle. So once we are just able to understood this exact operating principle and working of this four category, right? So then you could able to do energy management on these four things. So this is what our ultimate aim. So right, so as a energy management people, we need to do energy management on these four CHP plant, right? So before managing energy management in these four category, we need to understood, right, what's happening inside that these four things. Then only we could able to manage, right? So management நமக்கு தெரியும் இல்லையா? First of all, we need to observe, or we need to study the existing system. Then only we could able to measure what all the quantities has been utilized over that machine. Then only we could able to monitor. Then only we could able to control. So this is what energy management oda taraka mantra, right? So we need to understood, and we need to monitor, we need to measure, and we need to control, and finally we need to manage, right? So without these 5 points, we couldn't able to manage anything. So first of all, what we are just going to do, so today we are just going to see about what are the things is going to happen inside that steam turbine, combined cycle, and IC engine, and gas turbine, how it's going to work and how it's going to generate electricity energy. Because topping cycle and அதுக்கு கீழ தான் இந்த 4 category வருது. So the ultimate aim of this four thing is going to generate electrical power, right? So in what are the different ways will be available to generate electricity energy, there is a major aim in topping cycle, right? So once we just finished these operating principle working, and then we'll directly move into energy management on cogeneration, right? So we'll go with it. This is a topping cycle which we just now discussed. Topping cycle in the sense, we are just going to first of all we are just going to generate electrical power, then we could able to generate thermal energy. So this is a right example, and we'll go with step by step. Combined cycle CHP, right? So we'll go with it. CHP, we need to create heat, we need to create electrical power. So we are just going to generate heat as well as we are just going to generate electrical power. How we are just going to do, right? So here, for let us example, we'll go with the first step. So in our first case, we are having a CHP. This is called my first case. We are just going to start with it. First case, combined cycle CHP plant. So how it's working, we'll discuss, right? So here we'll have a turbine. So that is called, we are having a gas turbine, right? So we are having a gas turbine. So how it's working, I'm just going to explain, no issues, and we will have animation video also. You could easily understood how it's working. So before into that, I'm just going to give you overall idea. And this is a gas turbine is now a gas turbine or a shaft is now directly coupled with my generator, right? This is what my generator is now directly coupled with my gas turbine. So the gas turbine here is now work as a prime mover. So here the gas turbine is now act as a prime mover, which is going to driven my rotating part of my generator. How that prime mover, that is a gas turbine, how it's going to getting rotated. So this is what the operation over here will see how it's working in the sense, right? So initially that air compressor is going to compress that environmental air which is from that nearby environment, right? Here that air compressor is going to getting air from this environment area, and there is an air filter is now placing over here. We are just going to remove dust particle and moisture particle over here, and it the that normal air is now coming into compressor chamber, compressor part, right? That is called compressor chamber. So now we'll have n number of stages will be here, that is called induced draft fans, right? So we'll have separate stages around to 5 to 11 or 15 or 20. So based upon your requirement or maybe load requirement, they will have different compression ratio. And then the air is now getting in this direction, and here it's now air is compressed. Once air is compressed, so compressed air has some quality, right? So the temperature will be very high, compressed air temperature will be very high, and it has some pressure, right? That pressurized air and heat air is now allowed into my combustion chamber. So that compressed air is now entering into my combustion chamber, right? So you could see the compression chamber is now coming, and here I'm just allowing a natural gas or a petrol or a diesel gas, right? So we are, I'm just going to allow a natural gas or petrol here. Here already hot air, that is called highly compressed air, is now coming, right? So here fuel also coming. Definitely, there is a combustion is going to be takes place. அப்ப என்னவாகும், இங்க வந்துட்டு fire create ஆகும். That is called huge amount of fire. So fire has some power, right? So it has high temperature and high velocity flames. So on the air என்னவாகும், it's now going to hit into my turbine blades. அப்ப என்னவாகும், கண்டிப்பா அந்த blades is now hit பண்ணுச்சுன்னா such way that they just blade is now arranged. Definitely the turbine is going to be rotated. The turbine blades is rotated. So anyway, the shaft is now already connected with my rotating part of my generator also is going to be rotated. So definitely my electricity is going to be generated, right? So this is a one way of generating electricity energy in a combined cycle pulse. This is a first cycle, right? So this is one way it's now electricity is generated. So you could see that the hot air is now coming from a combustion chamber and it's enter into turbine blade, and it's now input வந்துருச்சு. Then turbine வந்துட்டு output வரும் இல்லையா, that is called my output flue gas, exhaust gas is coming outside from turbine. That again it's fed back into a combustion chamber, that is called heat recovery chamber, that is called heat exchanger. We are just going to allow that exhaust from turbine is now allowed into my heat exchanger. Already we know heat exchanger, there is a n number of circles of pipelines, water pipelines is now connected, right? And the water pipeline enna panna pora, I am using a electrical pump, and we are just going to pump a normal cold water into this pipelines, right? So n number of cross lines pipelines will be over there, and it's coming out. So now we are allowing hot air from a turbine to, we are just going to allow into this chamber. So definitely that energy conversion principle is going to be takes place. So this hot air has very high temperature. The temperature is now going to be absorbed by my water, right? So the flow, the water pipeline states, the water is now converted into heat. That's now heat energy is now applied to this water. That water is now converted into steam. So the steam further now it has high velocity and pressure. This pressurized steam is now again going into hit one more turbine, that is called my steam turbine. We are having one more side of the same plant. Adhe plant la somewhat or 200 meter away, right? So 200 meter away we'll have one more steam turbine. This steam is now again hitting this turbine. Again, we are having one more generator that is called turbo generator. So again here electricity also generated. So this is second method. So the same plant will have two types of electricity generation. Again, in steam here will high pressurized steam is coming. So once after this turbine kinetic energy is now conversion, the steam is losing its velocity, that is called speed, and kinetic energy lose panadum. Here low pressure steam varum, and low pressure steam I am just going to allow into my condenser. Condenser is going to be converted this low pressure steam into normal water. So again this water என்ன பண்ண போறேன், again நான் pump பண்ண போறேன், again heat exchanger உள்ள பண்ண போறேன். I am just going to again convert into electricity energy. This is second cycle. So here we are generating two different types of electricity generation. One is from gas turbine, so one is from exhaust heat exchanger, right? So these are two cycle of generating electricity energy. That's why it's called combined cycle cogeneration plant. Got a meaning? So this is a way of generating electricity. We are just going to generate electricity in a two cycle. So one is a gas turbine, one is heat exchanger. So this is why it's called combined cycle cogeneration. So now I'm just going to switch on into one small animation. You could easily understood how it's working, right? I'm just going to play one small video. You could easily understood, right, how it's working. One second, I'm just now switching to small animation video. You could easily understood. One second. Yes, got it. Yes, anyone just confirm me? I think my screen is shared, right? Yes, it's getting shared, right? Yes.
Yes, sir.
Yes, thank you. And you could see that animation, right? So gas turbine and combined cycle. You could have that exact main thing. Sorry, 1 second. Actually, I have solved a different tab. That is what a different one. Yes. Now you got my screen. Yes, it's getting started, right? So this is a small animation about combined cycle cogeneration. You could see. So it's a world leading company. You people already aware of that, right? Siemens, right? So world leading good company. They are just giving varieties of a gas generation, gas turbine generator, right? In worldwide.
The Siemens Flex plant is a combined cycle facility. That means that it uses two steps of energy production, combining two different energy-producing cycles. In the first step, electricity is produced using a gas turbine. It operates much like an aircraft's jet engine.
So this is a concept is I already told that this is a old technology, not new old one. So in World War II, right? So World War time, right? So they're used to flights, right? Flight and missiles, right? So aircraft. Right, the thrust is going to be generated by that gasoline engine, right, in an aircraft, which is right. And the aircraft, this same technology, same engine is somewhat modified to generate electricity. That's a major difference, right? So this is a old technology also. Here, the direct now I'm just going to explain.
However, the gas turbine in this configuration supplies power from its spinning shaft directly to an attached generator.
So this is a very easiest technology. So these are the blades. I already told that. So these are the n number of stages, right? So you could have that the inclined blades, right? The air is now. I think someone have mic. someone's mic. I think someone is speaking, right? Okay, thank you. And this is the intake side. So this is my compression stage, right? You could see the area of that intake air is now somewhat a huge blade, right? While moving into this direction, you could see that area of the turbine is going to be little very tight. So here that blue color shows that a free air is now intake, right? So Singapore compression started. You could have the different stages, around 15 stages, right? And in this compressed air is now a little hotter, right? It's more hotter because of due to compression in different various blades, and air is now moving this direction because in such way that the blade is now designed. The air is now looking, it's like induced draft blades. Now it's moving this direction. You could see this gray color tubes, right? So we have a different gray color tube that is called, we are just going to inject a natural gas or petrol, right? Liquid petroleum gas like this direction. If you're just going to allow natural gas over here, definitely here hot air is coming and fuel is coming. In this place, there is a huge fire is going to be getting ignited. So definitely here in this place, there is a huge fire is going to develop. That's called. So definitely that fire is now it's more temperature, more velocity, right? So it's like a bomb, right? So here we'll have different types of blades we are having. That is called a exhaust fan, like, right? So it's not going to hit in this turbine blades. Definitely the turbine is going to be getting rotated. So this entire blade is now attached with my common shaft. This shaft is again coupled with my generator. This is called, here we could see generator. It's rotary part and stator part. This is my rotor part, my stator part. Once it gets rotated, you could able to produce a induced EMF over here. My stator side, you could able to generate electricity from a rotor side also, right? So you could able to change your rotor and rotor side, stator as well as rotor side. And we are just going to generate electricity over here. I'm just going to play it much time at I play pandra, you could see easily.
Generator to make electricity. Air is compressed in the gas turbine through multiple precision fan blades. This compressed air is mixed with natural gas, then ignited into a stream of high-energy, high-pressure air. The power of the pressure and extreme heat passes through a set of turbine fan blades, which spin the turbine shaft at 3600 RPM for 60 Hz markets or 3000 RPM for 50 Hz markets. The spinning shaft of the gas turbine is attached to an electrical generator, which converts this energy into enough electricity to provide a small city with all of its electricity needs. As the exhaust exits the gas turbine, it still has plenty of energy to utilize. This energy is used to power the second step of the flex plant combined.
So I already told that, right? So this is what my generator thing, right? So this is what my generator side, and this is what my compressor. This is what my gas turbine, right? So once this process is over, right, my exhaust gas, it will be coming out from this gas turbine. You could see that the red color, right? So it has some more heat. If this exhaust gas na environment release panama, now I'm just having one more setup. I already told that. So that is called a heat exchanger, heat recovery system, or heat recovery steam generator. That is called HRSG. They will, industry people, they will call it as HRSG. That is called heat recovery steam generator system. So this is called, it's like a building size. So in building size, inside that setup, we are just going to make n number of water pipelines, right? So these water pipelines carry normal cold water, right? So that cold water is now circulating inside that heat exchanger, and we are also here, we are just going to pass a huge amount of exhaust gas which is coming from this turbine is now moving away this chamber. So the entire heat is now transferred to into my water pipeline. So definitely the water is going to be converted into steam energy. You could see that steam energy in this pipeline. You could see that white color pipelines. Now the steam is now generated, and that steam is now going to sent around somewhere 200 meters away, and we are just going to allow, there is one more steam turbine will be nearby the question. This is high pressurized steam is going to be hit this turbine, and we'll have one more generator over here. It's also going to generate electricity energy. So here first cycle gas turbine, that is called, with the help of a natural gas or petrol or diesel, we are just going to generate electricity over here. And second stage, this steam is going to generate one more electricity. This two cycle of generating electricity energy is called combined cycle cogeneration technique.
cycle process. The excess heat of the gas turbine is routed to a specially designed boiler called a heat recovery steam
You could
generator.
see the temperature of this graphical view. You could easily understood, right? Inga pathina red color, in that pathina blue color. It shows that here very high temperature, here moderate temperature, it's very low temperature. So it shows that so the temperature of this flue gas is now going to convert into this normal gas, but in the in between heat transferring thing is happening because we are just allowing more number of water inside this thing. That water is going to be absorbed more heat and it's going to be converted into steam, and this exhaust gas is it loses its heat and it will be converted to normal temperature.
The hot exhaust flows past rows and rows of tubes filled with water, causing the water to boil and convert to steam. The steam is then routed to a steam turbine that is also connected to a generator, making even more electricity. The steam turbine is powered completely by leftover heat from the gas turbine's exhaust, which makes this combined cycle highly energy efficient, using less fuel for more power. Every step of the flex plant combined cycle process is
So here we are having a gas turbine based electricity generation. The same plant you will have a steam from that steam, that is this exhaust gas is coming from this turbine is now allowed to heat recovery steam generator station. Again that steam is now going to applied into one more high pressurized steam turbine generator. Here also we are just generating electricity energy. So you could see that two cycle of electricity generation is coming here. That's why it's called combined electricity generation. That is called CHP.
focused on efficiency, minimal environmental impact, and lower CO2 emissions
Because we are just using a low amount of fuel, that shows that we are just going to reducing carbon emission. You could able to reduce environmental impact, and you could able to increase the efficiency because we are utilizing every kind of energy which is developed inside that industry. இங்க இனிஷியலா பாத்தீங்கன்னா ஃபியூவல் எனர்ஜி டைரக்டா கன்வெர்ட் ஆகுது எலக்ட்ரிசிட்டியா. அகைன் எனக்கு வேஸ்டா இந்த ஃப்ளூ கேஸா போற ஹீட் எனர்ஜியை we are just going to convert it into again steam again converted into electricity. That's why efficiency of this entire plant is now going to be increased. So this is now currently many companies are moving into CHP type of power generation, but in conventional method they are just adding actually the plant to generate as a one more things, right? Just in olden days when they are just upgrading into CHP type of power plants
compared to traditional fossil fuel power plants. This process is very efficient, but how is its electricity actually created? The massive gas and steam turbine horsepower is used to spin the generator shafts, which convert the rotational energy into electricity. The shafts inside the electrical generators consist of a series of electromagnetic copper coils, which rotate within a casing lined with additional coils. The magnetic field of the rotating shaft coils excite the electrons and create a flow of electricity through the outer electromagnetic coils. This flow of electricity is directed to a transformer and distributed to the power grid. That's where a modern, intelligent, and reliable grid infrastructure is critical. Managing energy from various points of creation across distances to points of consumption.
because we're using different types of CHP. Definitely the output will be different and frequency of the power it will be somewhat different and load factor will be different. For integrating those things, definitely I need intelligent grid which is needed. That's why it's called smart grid, but I'm not going to take it smart grid right now. Already people already studied in lower semesters. But anyway, so with this I'm just going to conclude this combined cycle power generation, and we're just going to moving into a next type. So next type, anyone just to give me next type of your CHP. First type just now we have discussed combined cycle, and second one steam turbine power plant. So we have discussed about four types of topping cycle power plant. One is combined cycle, just now we have discussed, and now we are just moving into steam turbine combined heat power process plant. And then once we are just finished, we are just going to IC engine. We are just going to go with the gas turbine. So now we are just going to go with a steam turbine. So now I'm just going to move into steam turbine. So steam turbine is nothing but we are just our ultimate aim is that we are just going to generate electrical power. So that's why it's called a topping cycle CHP plant. So we are just going to generate a generate electrical power from a steam. So that's a major important thing. So we are just going to generate electrical power from steam. So how we could able to get a steam? So we are just going to boiling a water, right? So we are just going to boiling a water with the help of heat input, right? So we are just going to convert it to water into steam. That high price is the steam is going to be allowed into my turbine. So now definitely turbine is going to be getting rotated. Definitely my generator is also getting rotated, and I'm just going to be able to generate electrical power. So this is the first cycle. You just first step, we are just going to generate a steam with the help of water and heat. So second step, the water is now converted into steam and it's going to allowed into turbine. It's getting loaded and it's going to convert into electricity energy. That here in my front end, high pressurized steam is now coming. So once this work is done, here my low pressure steam is now coming outside from the turbine. And then second stage, I'm just going to allow this low pressure, low temperature steam into my condenser. So definitely now that condenser is going to be condensed. This entire water is now into cooling water. It's normal normal water again. It's now fed back into my boiler. Boiler again. It's going to be heat more steam and it's going to apply it here. So now the cycle is coming. So hot water, steam, high pressure steam and low pressure steam condensated. Now steam is now converted into water. Water again is now fed back into my boiler, feedback water, and again the water is now coming into my steam generator. Now again that cycle is going to be continued. So this is how the electricity is generated in steam turbine. I'm just going to share one more small animation video. You could easily understood how that steam turbine is working. So this is a normal conventional method. So in all over the world, how that coal-fired thermal power plant, how it's working, right? So the same entire thing is now we have just now discussed. In the technique that still now we are using coal-fired thermal power plant. So coal is now fired in boiler time. So boiler is going to generate a steam. That's right. So already we people very well aware of that. Now I'm just going to play that video. I just now shared my screen.
Nuclear and coal-based thermal power plants, due to its lift force along the stator, energy increases. As the energy comes, the fluid has three.
So these are turbine blades.
In short, the energy in the fluid transfers to the mechanical energy of the rotor. To further understand steam turbine operation, let's understand fluid energy in greater depth. The stator set is staged to keep the total energy.
So we need to rotate this turbine, right? So we need to rotate this turbine in a constant manner because this rotating turbine is now directly coupled with my rotating part of my generator. So if the speed of this turbine is continuously changing, definitely my rotor speed of my generator is also getting changed. So if the speed is continuously changing, so we couldn't able to generate a constant power supply. That is called frequency is directly proportional to a speed. That is called how that the speed is now changing. Definitely my generator to power supply frequency is also changing. F is now directly proportional to my rotational speed of my turbine. So we need to make this turbine as a constant one. So for this purpose, we need to have a high pressurized steam, right? It's always hitting this blade, turbine blades. So in such a way that we could able to maintain this steam turbine in a constant speed. How we are going to do? So I don't need any temperature because a high pressurized steam always have high velocity, high temperature, high pressure in nature. So, but my ultimate aim is that velocity is most important case in this here because this velocity of this high pressurized steam is going to rotate this steam turbine, right? So the temperature or the pressure, it's not going to help that much. So pressure also going to help this much, but its the temperature is not going to help this rotating of this turbine. The main thing is that velocity is much more important. So for the purpose, we'll have different arrangements, right? So you could see, so my silver color blade should be look like this. My one more gray color blade will be look like this. One more opposite blades. So we are just going to allow in this direction in the sense we are just going to allow the steam pressure in this direction in the sense the blade is going to be in this direction. Definitely now this what could I say? This turbine is now going to move a downward direction, right? So this is a movable one, but this is a fixed one. This is stator. This is called rotor. Now this turbine is now moving downward. Because of that, I'm just going to allow steam this direction. So such ways that in the blade in the direction definitely hit touch on the aerodynamic view and it's now going to downward direction. So appadikapra the released once he hit it பண்ணிடுச்சுனா the steam is now moving this area direction. It's going to in the பக்கம் பார்த்தீங்கன்னா high pressed steam it will be here. Here once that kinetic energy is now transferred to this rotating turbine, so the velocity of this steam is now getting lower in this area. இந்த ஏரியாவில் ஹிட் பண்றப்ப ஹை ப்ரெஷர் ஸ்டீம் வரும், பட் இங்க லோ ப்ரெஷர் வரும். This low pressure steam is now going to this stator part. It is not movable blade. So in the angle வரும். Now we'll going to place one more rotating turbine over here. You could see I'm just going to play it.
Constant. Now the next row of rotors is added.
Now I'm again one more turbine is now added. So அப்ப இங்க பாத்தீங்கன்னா very high velocity turbine is now rotating and somewhat air is now moving this direction. Again என்னவாகும் இங்க low again steam is now hitting this plate and this plate is also going moving downward direction. In this way you could able to increase more number of kinetic energy of that steam. I'm just going to further continue.
The stator also makes sure that the flow coming out of it will be at an optimum angle of attack to the next rotor set.
So we should maintain this angle. It should be in such a way that only you could able to maintain the velocity. You could see velocity is somewhat like this, right? So in average velocity will be somewhat like this. So you could able to generate a constant frequency power supply. The average velocity should be like this. எனக்கு ஒரே ஒரு blade இருந்ததுனா definitely எனக்கு wouldn't able to generate the constant power supply frequency. That's why the arrangement is much more important here.
After that, another nozzle set is added. Many such sets are used in a steam turbine.
So this is called 15 stages or 20 stages
there is
based
an
upon
important term while
requirement.
designing steam turbines, namely degree of reaction. This term is calculated by dividing pressure and temperature. This is the reason. Otherwise, the flow speed will become too high. This is the reason why the steam turbine blades are too long towards the outlet. You can see how long the last stage turbine blades are compared to the first stage blades. The tips of such long blades will have very high velocity compared to the root. A twist is given to it so that all blade cross-sections will remain at an optimum angle of attack. This kind of large turbine uses two such symmetrical.
So here this is the inlet of my high pressurized steam is now coming and it's now split it into two area. Here we'll have blades, right? So in this white color blade shows that rotating movable part. This gray color part is now it's a stable part, so which is already fixed. It's not a moving, right? It's a movable. This is not a movable part, but it is a my silver color plate is now rotatable one. So then both ends. So this one end, one more end. So we are just passing high pressure steam over here. The steam is now getting split into two way, and both steam is going to hit it this silver color plate. Definitely the turbine is going to be getting moved, right? Rotate out, you could see.
Units.
Yes, this steam is now
you can
getting.
see how the steam is equally divided between these units. High-capacity power plants use different stages of steam turbines, such as high-pressure turbine, intermediate pressure turbine, and low-pressure turbines.
We'll have three
All
different
these
types of
units are
turbine.
attached to a single rotating shaft.
So this entire turbine, this is a very high pressurized turbine, and this is an intermediate turbine. This is a low pressurized turbine. Because in that initially I'm just going to allow more pressure which is coming from this boiler unit. So ingarada vegam varapodhu, it's now going to be getting rotated which much faster, and we'll have the shaft is now connected with one more turbine and one more turbine. So இது மூணுமே நான் வந்து ஒரு இடத்துல நான் ஸ்டீமை ஹிட் பண்ணல. We'll have three different stages. So anyway we could able to have much twisting force on this entire torque. ஒரே ஒரு இடத்துல நான் ஹிட் பண்ணா ஸ்டீமை ஹிட் பண்ணா I couldn't able to create that much twisting force, that is called my torque. So if you are just able to hit in three different area with a different diameter of a turbine, you could that entire thing is now connected with a single shaft. So we could able to have different angle of attacks, right? Different angle of steam attack. So then you could able to generate more a stronger twisted force, that is called more strong a torque could able to generate this entire torque. That's why it's now split into three category, and this entire shaft is going to be connected with my generator. So that further generate electricity energy is going to be generated.
The shaft in turn is connected to a generator.
You could see the generator is now coupled with the main shaft.
The reason for such different stages is quite interesting. With greater steam temperature comes greater power plant efficiency. This is according to the second law of thermodynamics. But we cannot have temperature greater than 600 degrees Celsius since the turbine blade material will not withstand temperature more than that. Temperature of the steam decreases.
So this is why that steam turbine is going to be generate my electricity, right? With that, I'm just going to moving into next type of thing, right? So I'm just going to pass it over here, and we are just moving into another type. So we have discussed about two types. One is combined cycle power generation of electrical power, right? So second type just now we have discussed, that is called the steam turbine based one. And third one, so what is the third one? That is called IC engine based. So first type combined cycle, second one steam turbine, third one internal combustion based. So this is my third time, so internal combustion. So we will have internal combustion like my car engine. So in our car, it's Maruti 800 or maybe Omni, we are just having an internal combustion engine. So why it's called internal combustion engine? Because the combustion is having takes place inside my cylinder, right? So that's why it's called internal combustion engine. We are just allowing a natural gas or maybe a petrol or liquid petroleum, right? We're just going to allow, and there is a one more path is coming, that is called my air filter and air compressor. That is called air is now compressed and it is now fuel also is now coming inside cylinder. So there is a compression, there is a compression will be takes place, there is a air also is coming, there is a mixture. Definitely huge fire is going to be developed inside the cylinder. Definitely the piston is also going to be move on upper direction. That crankshaft is also connected, shaft, that crankshaft is now connected with my shaft. The shaft is going to be rotating. The shaft is now connected with my generator. Generator is also going to be generated. In your home or motel or hotels or residential areas, there is a generator in banking, right? In bank, hospital, right? So there is a generator is now running. So this exact principle is now working. So IC engine is now directly act as a prime mover to this my generator, and it could able to generate electricity energy, right? So definitely huge fire is going to be developed inside that my cylinder, right? So definitely heat is also built up, right? So here I'm just going to have a coolant system. Here I'm just going to have a coolant system, that cold water is going to be flowing around this entire engine, that is called IC engine. Definitely I know that normal cold water is going to be converted into heat water. Again, we are just going to use some heat purpose in our homes, right? So hot water use panikalam, or maybe different application industry use panikalam, and exhaust gas is now getting eliminated. So this is what internal combustion engine. Your bike kept your car, bike would entire same principle as well as my car, truck. So these are the things called IC engine. So IC engine movement inside cylinder piston is now moving upper downward direction. This is called a linear motion. So linear motion எப்படி takes place ஆகுது, two stroke engine or four stroke engine causes, right? So two stroke two only compression and exhaust. One is combustion chamber, one is exhaustion step. In my four stroke, we'll have four types of air intake, fuel intake, compression, combustion, exhaust. These are four stages. In two stroke engine, we'll have more power. In four stage, four stroke, we'll have more fuel consumption, more managing of a fuel consumption, but will not have that much torque. It going to be developed. But in my two stroke, much torque is going to be developed, but fuel consumption is very high. So that's why a two stroke RX 100 bike light, it's going to consuming more power, but power delivery is very high. In four stroke engine, you will have good mileage, but torque will be very less. So the same way, I'm just going to here we're just going to discuss. Now I'm just going to moving into one more small video, and you could see IC engine based CHP. IC engine based CHP. So here I'm just going to show you diesel energy, diesel as a fuel here. Only 5 minutes more.
Rotor of an alternator by prime.
You could see the piston is now, we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 cylinder, that is called a V. It look like V shape. You could see like V shape. In the pakka 10 cylinder, on the pakka 10 cylinder. So totally 10 piston, in the pakka 10 piston. So here we'll have 10 fuel injection techniques, that is called spark plug plus arrangement. That is called fuel setup plus spark system. and we'll have you could see this pipelines called a coolant system. We are just going to allow for water flow over here, and these lines is called my compressor. Air is now coming into this system.
This prime mover can be driven using different types of fuel.
You could see two pistons now running here in this direction and this V direction. If you are just ignition inge start ஆச்சுனா இந்த பக்கம் push பண்ணும், அந்த பக்கம் start ஆச்சுனா அந்த பக்கம் push பண்ணும். You could see that crankshaft is here also. So this crankshaft is now moving up and down this direction. There is a rotation is going to take place, and this is a common 10 cylinder is going to be connected in a single shaft. So this 10 cylinder is going to be connected in a single shaft. This single shaft is now act as a this single shaft is now again coupled with my generator. Generator is going to be generate electricity.
For generating electricity. So, when prime mover of an alternator is diesel engine, then the power station is known as diesel power station. Let's take a look at the diesel power plant. The various subsystems of a diesel power plant are prime mover, starting system, lubrication system, exhaust system, cooling system, air intake system, and fuel system.
Definitely we need a fuel system, air system, compression, exhaust, and heat removing oil system. Oil. Bike la patripingla, car, bike oil, we need to change.
In a diesel power plant, prime mover is a 2-stroke or a 4-stroke multi-cylinder diesel engine. The starting system. Starting system provides the initial rotation to the engine shaft required to start the engine. Smaller units can safely be started manually by hand cranking. However, larger units use compressed air for starting purpose. Lubrication system. Lubrication system consists of lubricating oil tank, pump, filter, and oil cooler. Lubricating oil is drawn from the oil tank by the pump and is passed through filters to remove impurities. Oil coolers are also there to keep temperature of the oil as low as possible. Exhaust system, as the name suggests, leads the engine exhaust gases out to the atmosphere. A silencer is used to reduce noise level. Air intake system intakes the air and supplies it to the engine for fuel combustion. Its air filters remove dust from air before forwarding it to the engine. Air filters can be dry type, made up of wool or cloth. Fuel system. Fuel system consists of a storage tank or the main tank to store the fuel. The oil is pumped into the day tank via transfer pump. During the transfer, the day tank to the main tank. Fuel injection pump injects the fuel from the day tank into the engine cylinder at a high pressure of about 100 bars. Cooling system. Cooling system is instrumental for the liquid cooling process. In this system, cooling jackets are provided on the engine cylinder walls and head, through which the coolant is circulated. The heat is transferred from the cylinder walls, is cooled while it passes through the air-cooled radiator. So this is how a diesel power plant works. Now,
okay, with that I'm just going to wind up today's classes. These are the different varieties of CHP systems. So and tomorrow we're just going to continue. So thank you all. Thank you all for joining. We have just crossed the time. So thank you all.
Thank you, sir.
Thank you, sir.